Okay, so let's talk about, the next unit is compound angles. Compound angles. And we'll talk about other things in this video. Angles are basically the sum and the difference of two angles. So, for example, yeah, well, the form, you might see pictures like this. So, you have like theta and beta. And so the question is, what is the sine, cosine, and tangent of the sum of two angles? And so you're given the formulas. So the sine of, let's call it A and B, is equal to the sine of A cosine of B plus the cosine of A sine of B. And the cosine of A plus B is equal to the cosine of A cosine of B minus the sine of A sine of B. And look this up and look for the proofs of this. We're not going through this. This is starting to get a little old school, but it is part of the curriculum. It might be on the IB exam, but once again, you have the sum. To find the difference of A minus B, just replace B with negative B in the equation, since cosine is, so we have the sine of A, we haven't changed the A, but because cosine is an even function, we still have cosine of B, but if we replace B with negative B, right, and we know that sine is odd, we now have minus cosine A sine B. Once again, you're given these formulas. What's going on here with the difference formula? A minus B, same idea, replace B with negative B. So we have cosine A, cosine B, because cosine is an even function, so the cosine of negative B is equal to the cosine of B. And what's going on here, the sine of B is, the sine of negative B would be negative, so we have plus sine of A, sine of B. Yeah, it's a little tricky, it's a little weird. This is a plus, that's a minus, this is a minus, plus. Once again, you have in the formula, just look at the formula. What else? So for example, what are some things we can do with these formulas? As I said before, look up on the internet how they came up with this. It's kind of interesting. So for example, why do we need this? Well, let's say I asked you the sine of 75. Well, you have a couple of options. Maybe in the last unit, because hey, Mr. Adler, that's 1/2 of 150. You could do that, or we can say that 75 is in fact 30 and 45. And so we plug it in the formula, the sine of 30 with the cosine of 45 plus the cosine of 30, the sine of 45. Can you see that? Yeah. And so we get, let's just take a look at this. So it's 1/2 radical 2 over 2 plus, radical 3 over 2 plus radical 2 over 2. And we get the answer, kind of interesting, radical 2 plus radical 6 over 4. It's a weird answer. It would be like a part 1 question where you'd have to know this. Once again, this is an irrational number. This is that exact number. Radical 2 plus radical 6 divided by 4. Hey Siri, radical 6 plus radicals 2.
The answer is approximately 3.8637.
Hey Siri, 3.8637 divided by 4.
3.8637 divided by 4 is about 0.9659.
Whatever this irrational number is, that's what this is. The sine of 75 is this irrational number. Please remember, one thing we're always trying to do in math is fill in the number line. So that's what's going on here. Now we have the sine of 75. Let's do the sine of 15. The sine of 15, well, you can use the double angle formula, or Actually, or you can use the half angle formula. Well, no, yeah, the half of 30, or you can use the different. Let's change to the cosine of 15, knowing that it's the same thing. Let's just see how this works out. The cosine of 15 is the cosine of. You have a couple of options, right? You have, what do you have? I guess 45 and 30. Anything else? Can you do like 90 and 7? No. 130, yeah. 135 and 120, you can do that. Let's just check it out. So it's a 45 minus 30. So we're going to use the difference formula. Let's see, so it's this one. So it's the cosine of 45, the cosine of 30 plus the sine of 45, the sine of 30. Once again, you do not have to memorize these. Let's see, what do we have here? Radical 3 over 2. No, I apologize. We have radical 2 over 2. We have radical 3 over 2. Oh, I'm sorry. I apologize again. This is subtraction. That means this is plus. And so we have plus radical 2 over 2, 1/2, and we got the same answer. Radical 6 plus radical 2 over 4. That's what this is. So this might be like question 1, just work it out. Next. The next thing, let's do the tangent, because the tangent is kind of fun. The tangent, and watch the tangent of A plus or minus B is equal to the tangent of A plus or minus the tangent of B divided by 1 minus or plus the tangent of A, tangent of B. What's going on with these notations? This is in the formula book, so you have to understand what they're doing. The idea is, and I'll do this first one in red, if it's tangent A plus B, it's the tangent of A plus tangent of B over 1 minus the product. But if you're doing the difference, right, then it's A minus B is the tangent of A minus the tangent of B divided by 1 plus the product. Get used to seeing that. Oh, sorry. So, for example, you have a couple. Sorry. So, what are we? So you have a couple of choices. You first you try to derive it yourself. The derivation. Some of you might say, hey, you know what? So the tangent, for example, of A plus B is equal to the sine of A plus B over the cosine of A plus B. I'm not going to go through this because you don't need to know it. You're given the formula. I just want to kind of show you. We can take this formula and put it over this formula. And what you would do is you would divide every term. You would divide every term by cosine A, cosine B, and you'd simplify, and it would be all these tangents. That's the idea. So cosine A, cosine B. So you get sine A over cosine B. Cosine A over cosine B. You have sine B over cosine B. And same thing down here. This is a 1. Cosine A, this is tangent. That's the idea. Yeah. I'm sorry, yeah. There would be minus, and then the tangent. Hence, yeah. Now, am I going to ask you to do that? So, no. So, once again, yeah. So, there's a couple of fun things with tangent formula. This is fun. So, there's a couple of things we can do, and so let's talk about that. The first thing is, I'm going to propose this question to you that you've never seen before. The question is, So the question is, so fun with tangent. Because tangent is really important. It shows up. So the question is, my question to you is, given two lines, y equals x plus 3, and let's see, y equals negative 2x, I want you to find the angle between those two lines. So we have, here's our graph. Here's our first line, y equals x plus 3. Here is the line y equals negative 2x, and I would like you to find this angle. What is this angle here? And you've never thought about that. Who's ever asked you that before? But now, with trigonometry and the tangent formula, we can figure this out. Now, before we solve this problem, maybe you want to take it outside, figure it out on your own. Before we solve this problem, we have to revisit arc functions. So I'm going to pause the video, and when I come back, the board will be erased. Okay, I'm back. So we have to revisit arc functions. And what was the idea of arc functions? Once again, let's review the whole concept of this course is about functions, mapping x values to y values. Well, for trigonometry, we're mapping, for sine, cosine, and tangents, we're mapping an angle to a ratio. That's it. That's all we're doing. The sine of 45, radical 2 over 2. Tangent of 30 is 1 over radical 3. So once again, angle goes to ratio. So that means the arc sine, arc cosine, and arc tangents take the ratio back to an angle. So when you see the arc sine of 2/3, this is an angle. This is an angle, right? That's the idea. Once again, I can make my picture because I'm totally into my pictures. This is 2, this is 3, this is radical 7, this is radical 5, right? Because 9 minus 4 is 5. The idea is that the sine of theta is 2 over 3, whatever that theta is. Therefore, the arc sine of 2/3 is this theta. So once again, whenever you see arc sine ratio, you're like, oh, that's an angle. Done. Right? So we get these really interesting exercises where they say, what is the sine of the arc cosine of 4 over 5? You're like, what is that? Well, you say, okay, no big deal. The arc cosine of 4 over 5, that is an angle. This is an angle. Let's call that A. Well, I'm going to draw a picture because I like my pictures. So I'm going to draw my picture. I always put it in the first quadrant. It could be in the others, but you know what? I like the first quadrant. So I'm like, okay, here's my A. 4 over 5. It came from this. Right? So I know that the arc cosine of 4 over 5 takes me back to this angle. It's A. Right? So it's the sine of A. And therefore, what's the sine of A? Well, that's equal to 3 over 5. And that's it. That's the idea. Arc cosine takes you back to an angle, and the sine of that angle takes you back to another ratio. It's very straightforward. You can make up any one. You can say, the tangent of, the arc secant, of 7. Right? And you say, okay, this is an angle. Let me get my triangle. Let's call this angle B. Right? So let's get my picture up. Right? There's some B. Right? I know that cosine is adjacent over hypotenuse. So that means secant is hypotenuse over adjacent. Yes, hypotenuse over adjacent, right? Once again, cosine is adjacent over hypotenuse, so the cosine would be 1 over 7, but so the secant is 7 over 1. This takes me back to some b. I don't know what the b is. I can use my calculator, but I don't know. Now the question is, now I have this angle b. How do I get to tangent? Easy. Well, let's see. This is radical 48, and therefore the tangent of b is equal to radical 48. That's it. That's the whole idea. So let's continue. Let's continue. This might show up. Just to throw kids off. This is a part 1 question. What is the sine of 2 times the arc cosine of 1/4? You're like, what's going on here? First of all, what are we seeing here? What are we seeing here? Well, I'm sorry. What are we seeing here? This is old school, but it might show up on part 1. What do we see here? Well, first of all, I see an angle. Let's call that angle C. And I see a double angle formula. I see sine of 2 times this angle. First of all, let's get the triangle set up for C. So I know that I have a triangle, here's C, adjacent over hypotenuse. This is radical 15. Therefore, good. So the question is, what is the sine of 2C? And you say, okay, Mr. Adler, that's just the double angle formula, which is 2 times sine of C cosine C. And we're good to go because we have the triangle and we can find any of the ratios. So I know that the sine of C is radical 15 over 4, and I know the cosine of C is 1 over 4. Final answer, 2 radical 15 over 16, or radical 15 over 8. It's tedious, but it might show up. So you need to know how to figure this out. One more thing that probably won't. They put it in the book. They put the example in the book, but it won't show up on the AB exam. It's a half angle formula. So the example they give you is, what's the last example? The tangent of 1/2 arc sine of 2/3. Now, the book is only doing sine and cosine because they're waiting to the last chapter of 12 to introduce the reciprocal functions. We did it already, so we know what's going on. Let's just why don't you figure this up? Now, I'll say it again, because IB is not giving you the formula, they're not going to ask us, but we can do it. It never hurts to know. Once again, this is an angle. What should we call it? Angle D. And we have, the tangents of 1/2 D. Well, first of all, let me get my triangle down. So I know that this is angle D. Sine is opposite over hypotenuse. This is radical 5. And therefore, I know that the 1/2 D was the square root of 1 plus cosine of D over 1 minus cosine of D. Was that right? Let me check that from a couple of days ago. Let's see. Well, yeah, let's assume it's correct. Yeah, cosine is... No, sorry. No, it's the other way around. That's okay. And so the question, do I have to figure out what D is? No. We know the ratio for this. So it's the square root, 1 plus radical 5 over 3, divided by 1 minus 5 radical 5 over 3. You're not going to be asked it. If you need to know, you first of all multiply everything by 3. So you got the square root of 3 plus radical 5 over 3 minus radical 5. maybe you learned last year, and you can skip over this if you want. You rationalize the denominator, so it's 3 plus radical 5, 3 plus radical 5. This is equal to, let's see, this is 3, because it's 3 plus, so it's the square root of 3 plus radical 5 squared over, remember this is the difference of 2 perfect squared, 3 squared minus radical 5 squared, so it's 3 minus 5, which is 4. Final answer, the final answer is 3 plus radical 5 over 2. Okay, let's continue. Let's go on. Sorry. Okay, now let's solve a problem. Now we're ready to solve the problem that we came up with. Nice. The question was y equals x plus 3 and y equals negative 2x. So let's take a look at this picture. So we have this angle here. So I don't know what this angle is. Now, and I have this angle here. Let's see. So I have 2 angles. I have this rotation. Let's call this theta 2. And this rotation here, theta 1. Right? Because the angle, if we think about this, I generally don't ask you to, we never ask you to think about lines as rotations. But if you think about it, and once again, going back, if we look at y equals x, this is 45 degrees. So we know that this is 45 degrees. And then radical 2, let's see, y equals negative 2x. This is some other rotation here. Yeah. Okay, so we have the 2 angles. Yeah, nice. So we start, good. Okay, so the question is, I want to know what this angle is in here. And so you would say, okay, that's no big deal. That angle is equal to theta rotation 2 minus rotation 1. Okay. And so, sorry, someone's... Okay. So the question is, what are we going to do this? Well, this is kind of cool. What we're going to do is we're going to take the tangent of theta, which is equal to the tangent of theta minus theta 1, which is equal to the tangent of theta minus 2 minus the tangent of theta minus 1 over 1 minus 1 plus the tangent of theta 1 times the tangent of theta 2. So we have that. So you might say, well, Mr. Adler, what is the tangent of theta over 2? Well, let's go back to our original theorem. What did the tangent take the angle to? You say, well, it takes us to a ratio. Well, what does tangent take an angle to? It takes us to opposite over adjacent. Well, that's y over x. And you should say, that's the slope. Which means the tangent of theta 2 is negative 2. The tangent of theta 1 is 1 over 1 plus 1 times negative 2. Once again, the tangent of theta is the slope. This is y over x. So, let's see what I have here. We have the tangent of the difference is equal to negative 3 over, let's see, negative 1, which is 3. And then you time the arc tangent of 3. Hey Siri, what is the arc tangent of 3?
The answer is 10 minus 1, 3.
Hey Siri, what is 1.25 radians in degrees?
1.25 radians is equivalent to about 71.62 degrees.
And so we see that the angle between these two lines is 71 degrees. Once again, we have two lines. Y equals x at 3, started out here and rotated. We know it's 45 degrees. And we know that y equals negative 2x started here and rotated a certain amount. The question is, what is the angle between these two lines? Well, the difference of the angles, if we take the tangent of it, we use the formula, and then we know that the tangent of the angle is equal to their slopes, because the tangent of an angle is y over x, the rise over run. Just plug the numbers in the formula and use your graphic calculator to find the arctan of 3, and that's 71 degrees. The measurement of the angles between these two lines is 71.26 degrees. Let's continue. Fun with tangent. So more fun with tangent. Now, I'm going to show you an easier way to do this with vectors, but let's continue. Let's continue with some fun. The question is, find the arctan of a half plus the arctan of a third. What's going on there? Well, this is very straightforward. I'm going to show you an easier way to do this when we do complex numbers, but we don't have that tool yet in our toolbox, so we have to use our trig functions. So find the arctan 1/2 plus the arctan 1/3. Well, what did I tell you the arc functions? This is simply an angle. This is A, and this is angle B, right? That's it. So, you know what? If I'm adding angles, I'm going to take the tangent of the arctan of 1/2 plus the arctan of 1/3, and I'm going to use the formula. Well, the formula says it's the tangent of the arctan of 1/2 plus the tangent of the arctan of 1/3 divided by 1 minus the tangent of the arctan of a half times the tangent of the arctan of a third. Well, it looks crazy and complicated, but it's not, because what is the relationship between tangent and arctangent? They're inverses. So if arctan takes 1/2 to some angle, where does tangent take that angle? Right back to 1/2. If the arctangent takes 1/3 to an angle, angle B, what's the tangent B? Right back to 1/3. 1 plus 1/2 times 1/3. And so we get, what do we got here? We get 5 over, it's minus. Minus is kind of cool. You'll like this. Sorry. So we have 5 over 6 divided by 1 minus 6 is 5 over 6. We get equals to 1. And that means the tangent of A minus B, A plus B, which was the arctan or plus arctan, equals 1. Therefore, this is kind of cool. You ready for this? The sum, the arctan, is equal to pi over 4. That means the arctan of a half plus the arctan of a third equals pi over 4. Right? Yeah. The last one. This shows on the competition questions. You'll like this last one. This is kind of cool. Is it going to show up in an AP exam? No, but you saw it in a math class. That's the idea. You saw it in a math class. Last one. Let's see. Ready? You'll like this one. And you can try this on your own. Let's see. I want you to tell me what the arctan of 1 plus the arctan of 2 plus the arctan of 3 is equal to. I'm going to give you a hint. You know this is the answer to this one. I first find this. So I'm going to give you a second. Well, I'll give you a second. You can pause the video. So what is the arctan of 1 plus the arctan of 2 plus the arctan of 3? First of all, we're adding 3 angles. We're adding 3 angles. And you actually might have seen this before. You might have seen this before in this diagram, where you have 3 squares, and you're given oh, no, I'm sorry. You might have seen this before. I think it's this angle, yes, this angle, and this angle, and you're told theta, you're told that A plus B plus C, you're asked to add up something like this. You're asked to add up the angles. So you might have seen this before, something like this. Yeah, so let's figure this out. I think this is a little different problem. It kind of connects to that, but this is the solution for this problem you might have seen. So what's going on over here? Well, we have, I'm going to call this A. Well, first of all, I know the answer to this. This is pi over 4. So I don't know what's going on over here. Let's see. So we have I'm going to call this, what are we up to? Let's call this C and D. So I know the tangent of C plus D is equal to the tangent of C plus the tangent of D over 1 minus the product of the tangents. Let's see. C is the arctan of 2, so this is 2. D is the arctan of 3, so the tangent of that is 3. Let's see, we have 1 minus 6, so we have -1. That means this is, what is this? So where's the tangent negative? So this is like 1, it's kind of like, so the tangent of C minus D plus D is equal to -1. Therefore, it's not 45, it's 135, or 3 pi over 4. Therefore, pi over 4 plus 3 pi over 4 is equal to pi. And this is a great connection. This is bringing trigonometry and that number pi. Arctan of 1 plus arctan of 2 plus arctan of 3 equals pi. That's it. So are you going to be tested on this? No, but these are really interesting problems. Okay.